Alright, welcome to variables. So we've talked a lot about different kinds of variables, and this video is just kind of putting it all together. So try to follow along with me and fill in your notes as you go. So variables are your program's memory. That's how your program remembers things so that you can use them later and have it actually be useful. Where they are located changes what they are called. So the first kind of variable we ever dealt with was the local variable. So a local variable, I created a class here called character. So a pretend role-playing game type game, and I just created a basic class for it. So I'm just going to show you how that we can use this. So I have my methods, my constructors, and things like that. So inside this one that I called eat, I declared a variable called int gain. So this is considered a local variable. A local variable is located inside a method or a loop or any block of code that exists. So if you have, this is my method, I declared it inside this method, this is called a local variable. The next kind is the field. So these are the ones that have the only ones that can be private or public. So these are shared by the entire class. So I can use this anywhere in the class. So starting from where I declare it, it's inside this curly bracket, that's the closest curly bracket inside of it, all the way down to this. So anywhere in here, these fields are able to be seen or used. Okay, it's shared by the entire class. So these must be assigned a value in the constructor. So these two are our basic variable fields, and we have to make sure that they're given a value in the constructors. So these are my two constructors. Just as a reminder, constructors have the exact same name as the class with no return type. Okay, that's a constructor. So these allow you to come over here and create a game or a use for them, where I can create characters. So over here, this would be my default constructor, and here this would be my other constructor. So inside the constructor, I have to give my fields a value. So remember, if I do not give them a value, primitive types are 0. So that means integers and doubles are 0. Objects are null and booleans are false. So I don't want them to be, I don't want my boolean here to be false. I want it to be true. I want the character to be alive. And I don't want the HP to be 0. I want them to start their character out with 50 HP or health points. Okay, so what happens when you leave the private off when declaring a field? So I declared these fields. I have my getters and my setters. But what happens if I leave private, let's say off the HP? What can happen? So what can happen is when I go to my client program over here, I created two characters. Okay, what I can actually do is I can access me's HPs by just doing this. So this is a field. If I want to know how many HPs are in me, all I have to do is do me.hp, and that will allow me to see that it should have 50, because that's what I made it for my default constructors. There it is. Okay, so it allows, it's basically like saying that the safe is unlocked. So the get HPs and those kinds of methods are used to, make sure that you can't accidentally change values in a class. You have to consciously aware, open that safe and enter the safe. So I could actually do me.hp equals, or let's do plus equals 7,000. And I can just add 7,000 to my HPs accidentally, maybe some code or whatever. So that is this is why we always make it so that we need to have our fields be private, or else anyone can access them without the key. Okay, so if I go back And oh, not this one. If I go back and I make it private, what's going to happen is it's going to yell at me saying I can't access that. Oh, so let me compile. Okay, since HP has private access and character, so it knows HP exists, it knows what you're trying to do, but you can't access it without your getter or your setter. So I can't do this. I would have to do me.getHP and change them using the correct methods. All right, so you might think, oh, but it's so much easier to do it that way. But it's not. It creates general chaos, and anyone can accidentally change values that they shouldn't. So, all right. So next we have a parameter. So parameters are located in different places, and we want to say parameter is a noun, and all the other words we use to describe them are adjectives, but you need to know the adjectives. So the parameters are the way to pass a value or references to a method. So a parameter is the way to pass values or references to a method. We have two types, two nouns, well, no, two adjectives. I don't know, I'm sure there's names for adjectives, I'm not that smart. So we have the implicit parameter and the explicit parameter. So we're in the client program here. So here I'm in the client. This is allowing me to use the class. If I want to run a method, so let's say I want to run my method that I created, eat. So I want the person to eat. I need to have an implicit parameter. What person is eating? Okay, I want to be in game. So I'm going to have my character me eat. Me.eat. Now what am I going to eat? Okay, so that's telling me what I'm going to eat. So this one right here, that's your implicit parameter. It's telling me what character I'm going to be working on. So the implicit always comes first. Okay, and it comes before the dot. And then we have the method name. And then inside here we have our explicit, which we'll talk about in just a second. So the implicit parameter is always before the method name. It's telling us what object, it's always an object, what object to act on. Okay, the explicit parameters are the ones that's in the parentheses. So this is an explicit parameter, and to be more specific, this is a formal explicit parameter. So these are just the adjectives that go along with it. It's formal here, okay, the explicit parameters. In the class, when you're in the class, it's considered formal because you need the type and the name separated by commas. So when creating a method in the class, your parameters must have the type and the name separated by commas. So let's say I wanted, they not just eating one apple, they might eat 3 apples. So I could put another formal explicit parameter here by separating by commas. So this type name separated by a comma. This would be explicit parameters, but they're formal. They're in the definition of my method. When I come back over here, I don't have this, so I need to not have it here. When I go back here to the method call in the client program, when using the method in the client program, all you need is the value. So you could either have the value here, so that's apple, or you could have a variable that would represent that apple, like you inputted it or figured it out in some other way. I just haven't done that. Okay, so this one is called the actual explicit parameter. So when it's in the client program, it's actual. It's what the value actually is. Okay, when you're over in the class, it's just the type. It's just telling you what it would like you to send to it. Okay, so those are your parameters. So actual parameters are parameters that are in the method call. Then we have another kind of variable that I don't have in the actual notes, so you should write it somewhere else. It is the static variable. So here I have a field, it's a static field, and it's characters in game. So it's keeping track, so I say I have 50 people playing the game, every person will have access to how many people are in the game. So it's not individual. So me, in my client here, me has 50 HPs. This one has 300 HPs. Another one might have 55 because they fought in a battle or whatever. That is individual to each one of the objects. But a static field is only accessible by the class. So it's basically exactly the same, not only accessible, but it's accessible by the class and each of the objects, and that value is exactly the same for all of them at any particular time when you're running the program. So for example, if I were to run me.get, now please notice when you're running these, if it's I have a static variable called characters in games, it should be a static method that gets it. Okay, anytime you have a method that's related to this one, it should be static when it's getting it, at least. Okay, so when I'm running this, so get characters in game, no matter what runs this, so it doesn't matter if it's me, okay, if it doesn't matter if it's you, or it doesn't matter if it's the actual full name of the class. And you'll recognize this from running the math class. We just wrote the name of the class because it says static. All those were static methods. So as long as I didn't mess up anything here. Each one of these is going to be 2 because it doesn't matter, it's related to the class. And then if, say, I added another person here, so let's say her, now they're all going to be 3 because the characters in the game, they should all know at any time how many characters are in the game, always. So that's a static variable. Then we have a static, then we have a constant. So first we're going to do a regular final constant. So using the word final creates a constant. So when you're in a class, and it's one of the fields in a class like here, once given a value, it cannot be changed. So if it's a final here, you declare it here, you could give it a value right here if you wanted to always be 10 no matter what, or you can make it relative to the constructor. So I made my default constructor, it takes 10 every time they lose something in battle. Every time they go battle someone, they lose 10. Okay, but this one is, depending on what their HPs are, I divided that by 5, and every time they go into battle, that's how much they're losing. 1, so that if they only start with 5, they don't lose too many, or if they start with 7,000, they lose more than just 10. So whatever, it doesn't really matter why. So you can give them a value, you can do math to give them the value, it doesn't matter. So that is a final. Must be given a value in the constructor. Okay, you could give it outside of the constructor, but it definitely, if you don't give it here, it's going to freak out on you. So in other words, if I don't give it here or here, okay, now the statement. Yeah, it needs to be given stuff. Oh, here. Maybe I should do this. Go me. Yeah, variable lost in battle might not have been initialized. So we need to make sure we give it a value, even though there are default values. Okay. Then we have a static final. A static final is given a value in the class. So even if I try to give it a value here, it's going to yell at me. Okay, if it's static, if you have a static final, you have to give it a value up here. There's no other way to do this, and it has to be given a value. These must be gone. So a static final belongs to the class, so it cannot be given a value in the constructor, because constructors are individual to each object, each character in this case. So since this is individual to the character, and this is, no matter what, it belongs to the class, it has to have a value here. Okay? So then we have the benefits of a constant. So benefits of a constant makes the code more readable. So you see lost in battle instead of 10. Okay, it just makes more sense. It's easier to edit, so I can just change my 10 to 20 and I'm done. And no matter where I used it, it's going to change it correctly. Okay, finally we have scope. I realize this is long, but yeah, you haven't watched one in a while. So the variable scope, it's where the variable can be used. So you want to look for curly brackets. So you're looking for curly brackets or blocks of code. It's also where it is visible to the program. So how can the computer see it? Okay, this is the curly brackets determine that. So my curly bracket for the class is here. These are declared right after. So inside these curly brackets, this is alive, HP, cares in game, and HP lost in battle can be used anywhere from there all the way down to this curly bracket. Controversially, no, not really a controversy, but conversely, I guess, string food here is declared as a parameter, so it's part of this method, so it belongs to this section right here. It cannot be used anywhere else but here. Same with this local variable gain. Gain was declared here, so it's only good for here to the first curly brackets, you know, the one that closes, the closest one that opened it. So from here to here. Okay, so that's why we always said if you declare something inside a loop, you can't use it outside of the loop. That's scope. So you have to pay attention. There's a lot of that going on here. So if you have HP, this HP can only be used here. Good. All right, so we talked about a lot of stuff, all the different kinds of variables we know, from local to fields to parameters to static fields to constants, and then their scope. You are responsible for all this. I recommend you study it on a regular basis so you understand it. All right, have a good day.